Hello, my friend. Today we are going to discuss about bacteria cell wall. To understand the bacteria cell wall is very significant in medicine. So today we will discuss about that. You know already bacteria has two types. Number one, we have bacteria or we say gram positive bacteria, right? Gram positive bacteria. And second, we have gram negative gram-negative bacteria. Okay, so what is the difference between the gram-positive and gram-negative bacteria? So the difference is the cell wall. So let me draw the cell wall of the gram-positive and gram-negative, then you will understand. First, I will draw the inside membrane of two types of bacteria. For example, this is the inside membrane of gram-negative. Also here, the same. Gram-positive also inside membrane. And this inside membrane, what we call? We call cytoplasmic membrane. What we call? Cytoplasmic membrane. Actually, this membrane, cytoplasmic membrane of bacteria, it is the same the membrane of the human cell. This is made of the phospholipid bilayer. It is made of, this inside membrane is made of what? Phospholipid bilayer. Same human cell. Phospholipid bilayer. Bi means two. Bilayer here, bi means two. Okay, means two layer. And this two layer is made of phospholipid. Now, if I make it bigger or I just expand it, then you will understand. You see, like this. It is like this. Okay. And inside is a what? Lipid. Inside is a lipid here. Okay, the same for this gram positive also have two layers. In gram positive and in gram negative, they are the same. Okay, this layer, phospholipid bilayer. But in human cell, you know, in human cell, here. And what is the difference? Yes, the same is a phospholipid bilayer. But what is the difference between the human cell? Remember that in human cell, we have sterol. But the sterol of human cell is cholesterol. Remember, but in here in the bacteria, in this layer, they don't have sterol. They don't have what? The sterol. So sterol is the cholesterol in the human cell. Bacteria don't have sterol. So that is the difference between human cell and bacteria cell. Okay. Now, I'm going to draw the cell wall. You will understand. I'll remove this. Now let's image this is the cell wall. The cell wall of gram positive and the cell wall of gram negative. Both are made of what it is. So what we call glycan backbone or we call sugar backbone. Sugar backbone. What we call here? Sugar backbone. Sugar backbone. Or this sugar we also call glycan. What we call glycan. So you can call sugar backbone or glycan backbone. So it means the cell wall of the bacteria is made of the first component. First component is a glycan backbone. And then second component. So here, but here's the same in negative also. Here, remember negative bacteria. Okay, they also make of the sugar backbone here. Okay, but what is the difference between positive and negative bacteria? So positive bacteria, the sugar backbone is so much. Okay, so it means the cell wall is very thick. The cell wall of gram-positive bacteria is very thick. It's very bulky. It's very big. Yeah, you can image like this. This is the I'm drawing this. This is gram. Yeah, this is gram positive. So gram positive very fat, is very big like this. But you can image the gram negative. Yes, gram negative is very, very thin like this. Okay. So the cell wall is very thin. Few glycan backbone here. And then in between this glycan backbone, there is a second component, and that second component is what we call this is peptide chain. So it means these glycan backbone link together. They link together by peptide chain. And peptide chain is a second component of the cell wall. Okay, this is the what we call peptide chain. Peptide chain. Right? Peptide chain is the second component, and the sugar backbone is a first component. So both make of the cell wall. Here is the same. The same in the gram negative. Yeah. In gram negative bacteria, they also have cell wall. They also have a glycan backbone. They also have the peptide, but peptide chain is very few here. Yeah, that's why that's why this is very thin. Gram negative bacteria is very thin. The cell wall is very thin. Okay, but do you know what is the importance of the cell wall? You know, this inside membrane is very weak. That's why they need the cell wall to protect it. And what is the importance of this? First, they protect this inside membrane. Clear? And this make the shape of the bacteria. So cell wall make the shape of the bacteria. Because some bacteria, they have shape like this. You know already some bacteria, they have shape like this, circular. And some bacteria, they have shape like a rock like this. And another bacteria, they have another shape like spiral, like this. And some other bacteria, they don't have any shape. So the cell wall, first, you need to remember that the importance of the cell wall. The cell wall make the shape of the bacteria. Right. Okay. Now the second things, this is a very, very important things. So the cell wall protect this inside membrane, cytoplasmic membrane, because inside membrane they are hyperosmotic. They are this inside membrane is a hyperosmotic. What is hyperosmotic? Hyperosmotic means they tend to absorb water. Okay, they tend to absorb water. For example, when the bacteria are present in your body, in your mucosa fluid, in your saliva, or in your tissue fluid, and the solution or the fluid outside the bacteria is less hyperosmotic. Okay, but inside membrane is hyperosmotic, means they absorb so much water. So when the bacteria make new baby, For example, this is the one bacteria, and when they make the second two more bacteria, okay, the first they will make the inside membrane, and this inside membrane will absorb water, take water, and then at that time the bacteria also make the cell wall. Inside they will throw out the glycan backbone, and they also throw out the peptide chain to make the cell wall. Okay, and when they absorb enough, means when they are mature, inside membrane when they are mature, they absorb enough water, and this cell wall will prevent the water coming. Yeah, so it's prevent what? The cell wall. The importance of the cell wall is it prevent the osmotic burst. Osmotic burst. So what is osmotic burst? I said when bacteria make new bacteria. Okay, they make new bacteria, means they make new cell, and then means they make new baby. When they make new baby, first inside they will make the inside membrane first. Yeah, and I said this inside membrane is hyperosmotic. It means absorb so much water and they become mature. Yeah, and after that they will make the cell wall, and this cell wall will prevent the what? Osmotic burst means when they absorb water and they are very weak also, and then they become swelling. What? They become swelling. Means from small and they become big. Okay, they grow. They absorb water, they take water in, and they grow and they become big because swelling. But when they are mature, grow enough, and then they need that cell wall to prevent or to protect them, so the water cannot come in. So it is safe. In that case, it is safe. But what happened without this cell wall? Then you know the inside membrane will or bacteria will undergo the osmotic burst. Osmotic burst means the cell wall will burst. Sorry, the inside membrane will be or will burst. Then the bacteria will die. So that is the problem. So we know that. So we know that rule. We know that principle. And what we do, if we want to kill the bacteria, what we should do? We use the antibiotic drug. Antibiotic drugs. For example, we use the penicillin G. Penicillin G. Okay, penicillin G. Or we use the drugs beta-lactam in the group of penicillin. Okay, we have drug like beta-lactam. Okay, so this drug will come and prevent the formation, the synthesis of the cell wall. So it means this drug, when they come to the bacteria, they don't allow the new bacteria, they make the cell wall. Yeah, so they will come and prevent the formation of this cell wall. Yeah, so that's why the inside membrane, the bacteria continue to suck the water, to get the water in, and then swelling, small become big, big become more big, and then finally burst. Burst means die. Bacteria will die. So that is the way we use the antibiotic drug like penicillin G to kill the bacteria. Okay. Now that's the importance. Very important. One more thing I want to tell you that the difference between the cell wall of the bacteria, gram-negative and gram-positive. Remember, gram-negative bacteria have one more layer, additional layer. Okay, one more layer outside this cell wall. Okay, this we call lipid membrane. Lipid membrane. Okay, so this lipid membrane, they don't have in the gram-positive bacteria. Remember that. So that is the difference between the gram-positive and gram-negative. Okay, so when we want to use the, like if we use the penicillin G, come and destroy, okay, or prevent the formation of the cell wall here, especially prevent the formation of the peptide chain here. They cannot make the cell wall here. You see, if you prevent the formation of the peptide chain, then how the bacteria can make the cell wall? They cannot make the cell wall. Okay, and then they have only, you know, sugar backbone, so they cannot make the cell wall properly, and they will die. Okay, but if we use the penicillin G for this gram negative, what happened? So they have one more layer lipid membrane outside. So the molecule of the penicillin G cannot go inside and prevent the formation of the peptide chain here. So we cannot use penicillin G to treat the gram negative bacteria. So that's you have to remember. Okay, so in the next video, I will continue to share with you in detail, step by step, how the bacteria they make the cell wall here. Okay, so thank you so much.